Hi everyone, my name is Tarvin Sukumaran, metric number 223033344. I'm from group MET18. Our topic is bicycle brake caliper. In the next slide, we have listed our team members' name and metric number.
Assalamualaikum, my name is Noarifa binti Nur Amran and my matrix number is 223000417. So today we are looking at the dual pivot brake caliper, which is a standard but highly engineered component in the cycling industry. So at its core, it is a critical safety component. Its primary job is to convert simple cable tension from the rider's hand into a powerful mechanical clamping force on the rim. What makes the dual pivot design superior to older styles is its synchronized pivot system. This ensures that both brake pads hit the rim at the exact same time, providing balanced braking and significantly higher structural rigidity under the heavy loads. So in this analysis, we are focusing on three main technical objectives, which is the material integration, where we want to analyze how metal and plastic components work together in high stress assembly where failure is not an option. And then we also have manufacturing efficiency, where we are evaluating the trade-offs between cold forging for our structural parts versus injection molding for our adjustment components. And the last point for the objectives are optimization, which finally will look at the design improvements that could further reduce weight without sacrificing the durability required for high-speed deceleration. So basically, material and process breakdown. If you look at the table on the right, we can see two distinct manufacturing paths used in the assembly, which is for the caliper arms, the structural muscle of the brake. We use 6061T6 aluminum, which offers an excellent strength to weight ratio. These are produced via cold forging. This process is vital because it aligns the grain structure of the metal, making the arms much stiffer and more resistant to fatigue than if they were simply cast. So for the barrel adjuster, this is a secondary adjustment component. Here we use glass-filled nylon produced through injection molding. The addition of glass fibers to the nylon provides the necessary dimensional stability and heat resistance, while the molding process allows us to create the complex threads and knurling needed for fine-tuning the brake tension. So by understanding these points and manufacturing constraints, we can begin to identify where and how the performance gains will come from. So
this project aims to conduct a systematic engineering analysis of bicycle wheel brake calipers by dissecting their design, materials, and manufacturing processes and working mechanisms. Its performance will be evaluated and optimization solution will be proposed. Specific objectives are as follows. 1. Analysis of the integration of metal and plastic materials in high-strength components. Evaluated and comparison of the efficiency of key manufacturing processes. 3. Identify existing problems and propose design improvements to enhance durability and reduce weight.
Hello, I'm Tarvin. Now I'm going to explain about the components in dual pivot brake caliper and the material that has been used. Firstly, I'm going to explain about the pivot bowl material. Okay, the material has been used as steel. The reason why we are using steel is because pivot bowls experience high shear forces when braking force is applied. So steel is better because it has much stronger or higher shear strength compared to aluminium and plastic. Next, this steel prevents bending or failure force when strong braking force is applied, and then it has high surface hardness, which helps to reduce the wear at the contact points. The next reason is this will prevent looseness or misalignment over time. Okay, now I'm going to explain about the material has been used for caliper arm. So here we are going to choose aluminium. Aluminium is chosen because it is corrosion resistant, which has a naturally protective layer on top of it. I mean oxide layer, which prevent the corrosion. Okay. The next reason is it resistant to rust and in rain or humid condition. Okay, the next reason is it can withstand higher braking force without permanent deformation because it is aluminium. And then aluminium is strong enough, and this aluminium helps to dissipate heat energy during the braking. Okay, the next is brake cable clamp. Okay, brake cable clamp. This thing, the material used for this brake cable clamp is stainless steel. One of the reason is it is a corrosion resistant. The stainless steel resists rust and corrosion. It is strong and durable. The threads are durable because it must endure repeated tightening and adjustment during the braking system. So the perfect material, I would say the perfect material will be stainless steel for brake cable clamp bolt. Okay, next I'm going to explain about the return spring, which we are using spring steel. Okay, spring steel, it has higher elasticity where it can deform when braking and return to their original shape when the force is removed. The next reason is the spring steel, it is resist to fatigue, cracking and failure. And then this spring steel is a good wear and corrosion resistance because it has been coated, as I said before. The next part I'm going to explain about is the brake shoe. We are using aluminum alloy for the brake shoe. The material is aluminum alloy. This is because aluminum alloy is fatigue resistant because the ability to withstand repeated braking force is higher in aluminum alloy. The next reason is it ensures long service without structural failure. And then the next reason, I would say the aluminum alloy can withstand high operating temperature, which can prevent brake fade. The last item I'm going to explain about is the brake pads. For the brake pads, we are not using the raw material, we are using the reinforced rubber. Okay, this is because the rubber provides excellent friction when pressed against the wheel rim. Okay, so we need a softer item. So this rubber, the reinforced rubber, is softer than metal rim, which prevent scratching, cracking or excessive wear and rim wear. Okay, the next reason, since I said it is reinforced rubber, it is a combination of two materials. Okay, so there will be a backing plate in the brake pads. Okay, this backing plate is made of metal, which provides rigidity to the rubber pad, which does not deform excessively under high braking force. Okay, the last reason is the special rubber compound can withstand the heat generated during the braking without rapid degradation. So this is why we are using reinforced rubber during for the brake pads. That's it. Thank you.
Now,
I will talk about the mechanism and function of the bicycle brake caliper. The primary function of brake caliper is to convert the force applied by the rider at the lever into friction at the wheel. This reduces the bicycle kinetic energy and allowing the rider to slow down or stop. Next, the mechanism. A rim brake caliper mechanism uses a U-shaped frame with brake pads that squeeze the wheel rim to stop, activated by brake levers pulling cables, converting hand force into friction. The common types are single or dual pivot. Dual pivot offers better power for road bikes, while automotive calipers uses hydraulic fluid and piston to press pad against a disc rotor, generating friction to slow down the vehicles. In the previous slide, we discussed this as a common mechanism. Now, let's look at the details of rim brake caliper mechanism. Number one is the cable actuation, which is the input. The process begins with tension. When the rider pulls the brake lever, the inner stainless steel cable is pulled upwards through the outer housing. Number two is the leverage and force application. The cable is typically attached to one arm, which is the main arm. As this arm is pulled inward, a dual pivot system is engaged. Number three is the squeezing action. The design ensures that both caliper arms move almost equally and symmetrically, squeezing the brake pad simultaneously onto the rim of the wheels. Number four is the friction and braking. The friction between the high friction brake pad material and also the metal rim surface converts kinetic energy into the thermal energy, which is making the wheels slowing down. Last one is the return mechanism. When the lever is released, internal springs, which is the torsion springs of the knee, push the caliper arms back to their open positions, retracting the pads from the rim.
Now I would like to talk about the manufacturing process, which is involved for the part manufacturing. So for the first part, it is about metal part of the bicycle brake caliper, which is made out of an aluminium. Why aluminium is chosen? Aluminium is chosen because aluminium is a lightweight yet a strong metal. So the manufacturing process, which is considered as an ideal process to form the metal brake caliper, is a forging process. And why do we choose forging process? Forging process is chosen because of its improved mechanical strength due to its refined grain structure. That will be number one. And number two, it is about high fatigue resistance. And number three, reduce internal defects. And last but not least, it is suitable for safety critical components. And how do we make the bicycle brake caliper using forging process? So step one, aluminium billet is cut and prepared. Step 2, the aluminum billet is heated to soften the materials. And once the heated billet is placed into the forging dies. So the step 4, high pressure is applied on the forging dies to shape the caliper body. And number 5, so for the second part, it is about the bicycle brake rubber. The bicycle brake rubber is made out of nylon. Why do we choose nylon? Nylon is chosen because of its strong, lightweight, durable, and also resist to abrasion properties. And for the manufacturing process, we choose injection molding. And of course, we have a question why we choose injection molding as the ideal process. And we choose injection molding due to its high dimensional accuracy, mass production capability, low material wastage, and also the smooth surface finish. And for the processes of the injection molding, so the first step it will be nylon pellets are heated until they melt inside the barrel. And for the second step, it is about the molten nylon is injected into the closed mold under high pressure. And once it is injected under the high pressure, the material cools down and solidifies to form the desired shape. So in our case, it is cooled down to form the brake brake rubber shape. And last, the mold opens and the finished nylon part is ejected.
Okay, Hive, for this slide, I will explain the current problems of the parts and the impossible improvement. Okay, for the first, aluminium brake caliper may deform when exposed to the extreme braking force, especially during heavy or repeated braking. For the second, nylon piston can wear out or deform at higher temperature, which can reduce braking performance over time. Next, the brake sequence and vibration often occurs due to friction between components and slightly misalignment in the system. And finally, the bolts and fastener may corrode when the braking system is used in wet or humid environment. Okay, so to address this problem, several improvement can be made, which is we can use the high grade or heat treated aluminum alloy that can increase the strength of the calipers and prevent from deformation. And the second one is reinforced nylon materials such as glass fiber nylon can improve heat resistance and durability of the piston. After that, we can improve the surface coating that can help reduce friction, vibration, corrosion, and resulting for the quieter and more reliable braking. And the last one is better tolerant controls during machining can reduce misalignment, vibration, and overall noise. That's all from the slides. Thank you. To conclude this presentation, the bicycle brakes caliper is a critical safety component in the braking system. Aluminum alloys is chosen for the caliper body because it provides high strength while maintaining this lightweight. And then the forging process is used to manufacture the aluminum calipers, and it improve the strength and fatigue resistance compared to other methods. For the internal components, nylon plastic is used for piston and bushing due its low friction and good wear resistance. And the injection moldings allow this nylon part to be produced with precise shapes, good surface finish, and efficient mass production. After manufacturing, final machining and surface machinings are necessary to achieve the accurate dimension and improve corrosion resistance. And lastly, or overall, the combination of suitable materials and appropriate manufacturing process ensure reliable braking performance, durability, and rider safety.